Hey trigonometry class, this is the first of many of our lessons that we're going to be having here. And our first one is section 1.1. It's titled Angles. But in this section, we're going to be looking at some basic terminology in trig. And then we're going to move on to degree measures, something called standard position, and then coterminal angles. So let's go ahead and get started. So here's some basic terminology. First one is um, looking at our drawing here of a line. We should know that this is a line, and the name of it is line AB. It's according to whatever points are on the line is how we name it. The next one is called a line segment. This is just a portion of a line that is between 2 points. And these points right here, A and B, are known as the endpoints of our segment. So a line extends on forever in both directions. A segment is just a portion of that line that has endpoints. Okay, and then a ray AB right here. Notice that ray has one endpoint and then it extends on forever in one direction. And whenever we name our rays, A is going to be the first letter that we have, and that is our endpoint. And then B, the second letter that we have in the name, is the portion where it goes through B and extends on forever in that direction. Okay, so let's do an exercise. Well, before we get to an exercise, let's look at some more terminology here. Something about angles. An angle consists of two rays in a plane with a common endpoint. This is our common endpoint, which is called the vertex. And an angle is made up of two rays, and those two rays are called the sides of the angle. Okay, something about angles. An angle's measure is generated by a rotation about the vertex. So we start out here. This side of our angle is known as the initial side. And then when we rotate upwards, this side of our angle is called the terminal side. So you'll be hearing me mention initial side and terminal side in this presentation. So unlike in geometry class, we have, well, in geometry, we only dealt with positive angles. And many times those angles weren't any bigger than 180 degrees. Well, in this class, we have degree measures that are positive and negative. And our positive angle, how we're going to draw a positive angle, is this right here is our initial side, and we rotate it counterclockwise for a positive angle measurement. And this whole angle, this circle, near circle being drawn here, that is our angle. And then over here, to get a negative angle, again, this side right here is our terminal side, or sorry, our initial side, and we go clockwise motion and end up here with our terminal side. Whenever we go in a clockwise motion, that is a negative angle. So one full rotation is 360 degrees. So a complete circle, we should know, is 360 degrees. And just 1 degree is 1/360th of a rotation. So whenever I say something rotates 2 times, how many degrees did that thing rotate? Well, 2 times 360 is how many degrees it rotated. Okay, and you'll see that in our last exercise that we discussed. Here are some angles and how they're classified by their measures. We get an acute angle from the angle measurement being between 0 and 90. And then a right angle is always equal to 90 degrees. Obtuse angle is between 90 and 180. And then a straight angle is equal to 180 degrees. Before I move on, notice that this little symbol right here that we have is called theta. It's just a Greek symbol and or a Greek letter that we just in trigonometry we often use that to denote our angle measurement. Okay, so for our first example, we are asked to find the supplement and complements of a given angle measurement. So for an angle measuring 55 degrees, find the measure of its complement and its supplement. If you remember from geometry, we learned that complementary and supplementary angles, well, complementary angles are angles that add up to 90 degrees. Supplementary angles are angles that add up to 180 degrees. So let's find the complement of this angle. And the way you do that is you just want to say 90 degrees minus 55 degrees, and that is equal to 35. So 55 and 35 are complementary angles. Supplement, let's do the same thing except supplementary angles add up to 180 degrees. So take 180, subtract your 55 degree measurement that you're given, and we end up with 125 degrees. So the 125 degrees is the supplement of 55 degrees. Okay, so here to keep on going with complementary and supplementary angles, that subject, let's look at this exercise here. We have find each angle in this figure. So we're looking for this angle and this angle right here. And we know both of these angles add up to 90 degrees because that right there denotes that's a right angle, and right angles are 90 degrees. So we're going to say, let's find r first by setting up an equation of 2r plus 3r equals 90 degrees. Or you can just say 90 actually. And then solve for r. So this right here gives us 5r. Divide both sides by 5. We end up with 18. Now to figure out what each of these angle measurements are, just plug r back into this degree measurement and this one too. So we get 2r, or 2 times 18, and that's equal to 36. That's going to be in degrees. And then the other angle measurement is 3 times 18, and that gives us 54 degrees. Notice that these two angles, if you were to add them up, you would get 90, and that is hopefully what you do end up with each and every time that for measures that are supposed to add up to 90. The angle measurements end up equaling adding up to 90. Okay, these two angle measurements that we're asked to find, they are supplementary. So this is a straight angle right here. This whole thing is equal to 180 degrees. So take our 7t, add it to 2t, and then set that equal to 180 and solve for t. So we get 9t is equal to 180 and t is equal to 20. Now again, just like the last one, plug t back in for each of your angle measurements, and here's what you're going to get. 7 times 20, one of the angle measurements is 140 degrees, and then 2 times 20, the other angle measurement is 40 degrees. So these two angles that you end up solving for, they should add up to 180 degrees. All right, so in geometry, you've studied degree measurements, but you've probably never heard of minutes and seconds. Minutes and seconds are part of degree measurements. They're just smaller portions of a degree. So what we have here is 1 minute is equal to 1/60th of a degree. And then 1 second is 1/60th of a minute. So we're going to do some calculations and converting degrees or decimal degrees to degrees, minutes, seconds, and then vice versa. And that's where this stuff in here is going to come in useful. Before we get to the converting it from decimal degrees to degrees, minutes, seconds, and then the other way around, let's do this right here. It's asked us to perform each calculation. Whenever we are adding or subtracting degree measurements that include minutes and seconds, you just want to add those portions together. So we're going to add together 28 degrees and 63 degrees. And then we're going to add together the 35 minutes to the 52 minutes. And then we're going to simplify it. So 28 plus 63, and that gives us 91. And then 35 plus 52 gives us 87 minutes. Now, this number right here is what we need to simplify a little bit further. 87 minutes is much greater than 60. So there is another degree in here. 87 minutes is actually 1 degree and 27 minutes. So this is like having 91 degrees plus 1 degree and 27 minutes. So that calculation ends up giving us 92 degrees and 27 minutes. Okay, now on subtraction, since this right here is in degrees and minutes, and this one is only in degrees, we need to do a little bit of conversions here. 180 degrees is the same thing as 179 degrees and 60 minutes. So let's do the subtraction here. Let's just do it vertically. So when we subtract the minutes, we end up getting 31. And then subtracting the degrees, we get 62. So there's our solution for that one. All right, Trey, I'm going to do these next two problems on the calculator for you. If you want me to show you how to do these two problems by hand, I will do that in class. Just ask me. But for now, we're going to do these on the calculator. So the first one tells us, or asks us to convert this right here, this number, into decimal degrees. And what decimal degrees looks like is this one down here. And this one asks us to convert decimal degrees to degrees, minutes, seconds. So here's how you're going to plug it into your calculator. So turn it on first. Okay. You're going to say, make sure your mode is actually in degrees, just to make sure your calculator is calculating things properly in degrees. Okay. Get out of that. And now put in 105. And then where you're going to find degrees is actually hit the second apps button. And you'll see that stands for angle. And there's your degrees. Then put in 20. And again, go second apps. And number 2 there is your minutes. And then where you get seconds, you can find that in your catalog button. You just have to hit second 0. But here, look at the plus sign. there is in green on my calculator the quotation marks like that. That stands for seconds. So whenever you go in to put seconds, put in 32, hit the alpha button instead of the second button. So alpha plus sign, there you have seconds. And then just hit enter. And you have your value of that is in degrees, minutes, seconds converted to decimal degrees. Okay, now the next one, we want to convert 85.263 degrees into degrees, minutes, seconds. So just plug that in, 85.263, and then go back to second, apps, and do number 4. DMS stands for degrees, minutes, seconds. And then just hit enter, and voila, there you go. There it is in degrees, minutes, seconds. But on this last one right here, I don't want any decimal numbers when I'm asking you to put it in degrees, minutes, seconds. So round up to the nearest second. So the answer for this would be 85 degrees, 15 minutes, and 47 seconds. This page here is just another vocabulary word that we need to know. An angle is in standard position if its vertex is at the origin and its initial side lies on the positive x-axis. Okay, so your initial side is always going to be on this positive x-axis if in standard position, and your vertex is always at the origin. And then your terminal side is located somewhere in the first, second, third, or fourth quadrant. Okay? So a quadrantal angle, here again, we're talking about angles that are in standard position. Quadrantal angles are when the terminal sides lie on either the x-axis or on the y-axis. So angles whose measure are 90 degrees, 180 degrees, 270 degrees, and then so on, even 360 degrees, and you can keep on going around as long as you keep going 90 degrees each time. So see, 90 plus 90 is 180. 180 plus 90 gets you 270. Add 90 to that, you get back to 360. So keep going around the XY axis. All of those angles are what you call quadrantal angles. All right, coterminal angles. A complete rotation of a ray results in an angles measuring 360 degrees. Okay, so one rotation is 360 degrees. And by continuing the rotation, angles of measure larger than 360 can be produced, such angles are called coterminal angles. Okay, so here are a couple examples of coterminal angles. See this 60-degree measurement right here. If we add 360 to it, we come full circle and we end up with the degree measure of 420 degrees. These two are called coterminal angles because they differ by a multiple of 360. And let's look at this angle. We have an angle of 110. It looks like we go around the circle twice. So this differs by a multiple, two times 360. Okay, so 110 and 830 are coterminal angles. So for coterminal angles, to find an expression that will generate all angles coterminal with a given angle, add integer multiples of 360 to the angle that you are given. So for example, if you're given the degree of 60 and you're asked to find an expression for all angles coterminal to 60 degrees, then this is your expression right here. 60 plus some number n, so any counting number, 1, 2, 3, 4 on up, times 360. That will generate all angles coterminal to 60 degrees. So in this exercise, it deals with angles that are coterminal, and we're going to use the fact that coterminal angles are multiples of a given angle by 360. So this is asking us to find the angles of least possible positive measure coterminal with each of these angles given, A and B. Now, for the 1106 degree measurement, how we're going to get an angle that is coterminal to that one, and it's what it means by least possible positive measure. This means that your angle that you want that's going to be coterminal to each of these given angles, it's going to be something between 0 and 360. That's what it means by least possible positive measure, coterminal. Okay, so either add or subtract 360 as many times as you need to get an angle that is between 0 and 360. So for this first one, you're going to subtract 360, I know it to be 3 times. And when you subtract 360 3 times, you get the measure 26 degrees. And we're done. This is between 0 and 360. If you were to subtract 360 twice instead of 3 times, you would have ended up with a much bigger or a bigger angle than 360. So you would need to subtract it again. So as many times as you need to subtract or add 360 in this part right here to get something that is between 0 and 360. Okay, on this next one, it's a negative angle, so we're going to add 360 instead of subtracting. So take 150 degrees. We're only going to need to add 360 once. And when we add 360, we get 210. And we're done. That is an angle between 0 and 360. This is our last problem in this section, and what we're going to be doing is pretty much doing conversions to get our solution for this one. So here it says a wheel makes 270 revolutions per minute. Through how many degrees will a point on the edge of the wheel move in 5 seconds? So what we're doing is we have a wheel and a point on that wheel is moving. It's rotating 270 or revolving 270 revolutions per minute, and we're wondering how many degrees will that point move in 5 seconds. So to start us out, I'm going to say, since we're using seconds, let's convert 270 revolutions per minute to revolutions per second. So there is 1 minute in 60 seconds. And when we divide those two values, or multiply these two, the minutes cancel, and we end up with 4.5 revolutions per second. Now, multiply your 5 seconds to this 4.5 revolutions per second, and you will see that there are going to be, well, let's multiply 4.5 times 5. That gives us, in 5 seconds, this point on the edge of our wheel revolves or rotates 22.5 revolutions. Now, in one revolution, there is 360 degrees. So multiply this by 360 degrees. There's one revolution. So the revolutions cancel out. And you end up with this many degrees is how many degrees that point on the edge of the wheel moves in 5 seconds. And that's it. We are done with this section. And if you have any problems, you can ask me tomorrow in class. Goodbye, everybody.